sum, but now you are taking a continuous sum. Okay, now you are taking a continuous sum, you are not missing anything in between. Okay, so integration is a continuous sum, right? So it is written like this then. So you are taking integration from t1 to t2, that is you are taking a continuous sum from t1 to t2 of v dt. So this delta t is written as dt. Okay, is there any question in this? Yes, no?
No, sir.
Okay, and now what you are looking at is one of the most important result in the whole mathematics. Okay, so you can say among the top 10 results of whole mathematics. So this is called as the fundamental theorem of calculus. This is known as fundamental theorem of calculus. Okay, so in math text it will not be written like this, maybe. So see, what does this theorem tell you? So x2 minus x1 is what? It is the displacement. x2 minus x1 is displacement. And what is the displacement? It is integral of velocity with respect to time, from time t1 to t2. But then what is relation between the velocity and displacement? Or what is displacement? It is change in position. So what is relation between the velocity and position? We know that velocity is equal to derivative of position with respect to time. Right? Yes, no?
Yes, sir.
Okay, we know that velocity is derivative of position with respect to time. So see, if you want to find out the change in a variable, okay, whose derivative you know. Okay, suppose you want to find out change in a variable whose derivative you know, right? So I will just rewrite it here. Okay, so see, I want to find out x2 minus x1. So what is x? X is position. Okay, x is position. Now if you know derivative of this x with respect to time, so v is derivative of x with respect to time. So if you take integral of v, what will you get? You will get x, but within two limits. Okay, limits will be t1 and x at time t1 and x at time t2. Okay, similarly what I can say is I want to find out v2 minus v1. I want to find out change in this variable, change in v, from time t1 to t2. What will I do? So if I know the derivative, I know the derivative. Derivative is what? It is dv by dt. Right? It's acceleration. So then I can write down the same formula. Okay, I can write down the same formula. So what is the formula? Change in this variable. Okay, so change in velocity. What will that be? v2 minus v1. And what will that be equal to? So I know its derivative. I know the derivative of velocity. It's acceleration. So if I integrate acceleration from t1 to t2, okay, with respect to time, what I am going to get? I will get the change in velocity. Is this thing clear? So if you have some function, okay, whose derivative you know, you have this function whose derivative you know, and you want the change in this function, okay, change in this function suppose. So what you can do is you can integrate this function and you will get change in this function. So moral of the story is the derivative and integration, they are anti procedures. Okay, derivative and integration is anti-procedures, or you can say integration is anti-derivative or anti-derivative. Okay. Yes, no? I take derivative of one function, I get the second function. Then if I take integration of second function, I will get the first function. Yes or no?
Yes, sir.
I take derivative of first function, I get second function. If I take integration of second function, I will get the first function. Okay. Actually change in first function. Okay. So yeah, this is integration. And then if you take integral, okay, if you take area under the acceleration versus time graph, you will get change in velocity, right? Because acceleration is dv by dt. So this we saw. Then there is one more thing. So do you know chain rule of calculus? Chain rule of derivatives?
Yes, sir.
Okay. So we need to remember the derivatives, integrations. Okay. Okay, do I need to teach the sum rule, the difference rule, the product rule and the quotient rule of derivatives, or you know them? Yes or no? Okay, what is sum rule? Because we are going to need all of these things. Okay. Sum rule is very simple. You have one function, right? You have two functions. So suppose f is equal to g plus h. Okay. Then what will be derivative of f with respect to x? So it will be equal to derivative of g with respect to x plus derivative of h with respect to x. This is the sum rule. Okay, you know this, right? Then next is difference rule. Next is difference rule. So what is this difference rule of derivatives? So if you have f equals to g minus h, then df by dx is equal to derivative of g with respect to x minus derivative of h with respect to x. This is the difference rule, right? So derivative of sum or difference of two functions is equal to what? The derivative of first function plus derivative of second function if you have sum, and okay, it is derivative of first minus derivative of the second if you have a difference, right? So this is like common sense. There is nothing in these rules. Then next is the product rule of derivatives. Okay, so if you have f equals to g times h, okay, function f is g multiplied by h. All of them, they are functions of x. Okay, that means you have some formula of f g h in terms of x. Then if I want to take derivative of f with respect to x, it will be equal to derivative of first function dg by dx multiplied by second function as it is plus the first function as it is multiplied by derivative of second function. Okay. So does everybody know this? So g times
Yes, sir. Yes, sir.
g times dh by dx, and we write derivatives like this also. So g dash is equal to dg by dx, right? H dash is equal to, you can say, dh by dx. Okay, so this thing can be written as, what is dg by dx? It is g dash multiplied by h plus dh by dx is h dash, so g times h dash. This will be f dash. F dash is derivative of f with respect to x. Okay, so then there is, oh, I'm running short of pages. So then next is quotient rule. Okay, next is quotient rule of derivatives. So I have suppose f is equal to, okay, g upon h, or you can say u upon v. Then what will be this df by dx? So it will be equal to, in denominator you have h square, then you have numerator as it is multiplied by dh by dx minus h as it is multiplied by dg by dx. So this is correct? Yes, no? How we can derive it? Do you remember this, or there is a negative sign? So you have denominator square, then numerator as it is multiplied by derivative of the denominator minus h. Okay, so I can vary.
In the formula, v dash u is minus u v dash only, sir.
It is minus.
By v square. No, sir. V.
You have u upon v, v dash u minus u v dash.
V dash.
Right.
Divided by v square.
Divided by v square. Yeah. So this is correct. Okay. So. Okay. So if you have remembered this formula, that f is equal to u upon v, then this can be written as what? df by dx, okay, or f dash is equal to uv dash minus vu dash divided by v square. Okay. Right? Or this one is also so this is I'm sorry, gh dash minus hg dash divided by h square. Okay, so it doesn't matter. If you have remembered this formula, okay, stick with it. All right, so this is quotient rule. Okay, and then there is one more rule called a chain rule of derivatives. So what is chain rule of derivatives? So let's suppose you have a function which is function of another function. Okay, suppose you have g which is equal to, okay, g is a function of another function, h of x. Sorry, you have f which is equal to g of h of x. Okay, so I will give you example of this. For an example, I'm sorry, so suppose f is equal to sine of x square. Okay, so g is your sine function, but what is h? H is x square. Then I'm sorry. Okay, so now if I want to find out the derivative of f with respect to x, df by dx will be equal to what? So now g is not function of x, it is function of something else, some other function of x. So what will I do? I will find out dg by dx times dx by g is not function of x, g is function of h. So I will find out dg by dh and I will multiply that by dh by dx. Okay, so this is chain rule. So for an example, I have written the example. So see, f is not function of x. Okay, f is not function of x. F is a sine function which is function of x square. Okay, so what I will do is I will assume that in this sine, argument of the sine is x square. So I will say, suppose u is equal to x square. So what is my f? F is equal to sine of u. Okay, so then what I can do is I can take its derivative with respect to u. I know df by du will be equal to cos of u, right? But I wanted to find out derivative of f, not with respect to u. I wanted to find out derivative of f with respect to x. So what will be this derivative? So this derivative will be df by du multiplied by du by dx. Okay, so if you take df by du, what do you get? You get cos of u, and then you take du by dx. So derivative of u with respect to x, what do you get? Derivative of x square with respect to x, right? So it is derivative of this u with respect to x, and u is x square. Okay, so that is cos u. Now you can write down everything in terms of x. So this will be cos of x square multiplied by, you have derivative of x square with respect to with respect to x, it is 2x. So this will be your application of chain rule. Okay, is it clear?
Yes, sir.
Right? Then let's take another simple example. So suppose I have, okay, f is equal to this is sine of x square. Let's suppose we have sine, cos, tan. Okay, I have suppose e raised to, okay, suppose I have e raised to sine x. Now what will be its derivative? So what will be df by dx? So now my u is sine x. Okay, so I can write that df by dx is equal to what? Df by du multiplied by du by dx. So this is just like, you can say multiply and divide by du and du. Okay, so what is df by du? So your f is equal to what? E raised to u. Okay, so df by du, if you have e raised to x, suppose derivative with respect to x will be e raised to x only. You have e raised to u, its derivative will be e raised to u only.
Sin x.
Yeah, e raised to u, that is e raised to sine x. Then you have du by dx. So u is sine x, right? So d by dx, this is d by dx of sine x, and that is equal to e raised to u is e raised to sine x, okay, times you have derivative of sine x, which is cos of x. Okay, so this is how we find the derivatives using chain rule. Is it clear? Yes or no?
Yes, sir. Yes, sir.
Okay, so you might already know this, but I just wanted to make sure that everybody is on same page. So we saw it briefly. Okay, so now let us see some questions. So let's see this question. Which of the following curve does not represent motion in one dimension? So can you guess?
B, sir. Option B, sir.
Option B. Why?
So for the same time there were two velocities.
Okay, for the same time there are two velocities, right? So it is option B. Okay, So if there is anything which represents motion, any curve which represents motion, then the displacement, the position, velocity and acceleration, they will have only one value, one and only one value at any given time. Okay, so is it clear, Ganga?
Yes, sir.
Okay, good. So let's move on to next question. The displacement time graph of a moving particle is shown below. The instantaneous velocity of the particle is negative at the point.
Option A, sir.
Option A, sir.
Okay, it is option A, right? So instantaneous velocity, to find instantaneous velocity, you will draw tangent to the curve, okay, and tangent to the curve at E, it has got negative slope. So answer is E. That means the velocity is, it's negative. Okay, right, Ganga?
Yes, sir.
Okay, next question. A particle shows distance time curve as given in this figure. The maximum instantaneous velocity of the particle is around the point.
Option D, sir.
Option D is C.
Option A, sir.
Option A is D. Yes, what do you think?
In option D, its slope is decrease only, sir, as compared to option C.
Okay, first of all, they have not marked the points, right? They should have marked the points themselves. Okay, so see, I can draw here, I can draw here also. I don't know, right? So let's suppose these are the points. Okay, and then if we draw the tangents to the curve, so tangent at this point looks like this, tangent at this point looks like this, tangent at this point looks like this. So now slope of this tangent looks, so slope of this tangent will be highest, right? So that means velocity is highest at point C.
Okay, sir.
Right? So velocity is highest at point C if the points are marked like this. Okay, so actually they should have marked the points. So maybe this, okay, the points were there in the initial question, the original question, and maybe the book from which I adopted this, maybe they are not there. Okay, they are not there. Anyways, so next question. Two cars P and Q start from a point at the same time in a straight line and their positions are represented by, so these are the positions. XPT is equal to, okay, position of P at time t is AT plus BT square and position of Q at time t is FT minus T square. At what time do the cars have same velocity? So what should we do? We want to find out time when the velocity is same. What should we do?
We should differentiate that and equate that.
We should differentiate and equate. Okay, because we want to find out velocity of P when it is equal to velocity of Q. So this is given, velocity of P is going to be equal to velocity of Q at some time. We want that time. Okay, so this is derivative of xp with respect to t, this is derivative of xq with respect to t. So that is d by dt of at plus bt square, and this is equal to d by dt of ft minus t square. Okay, then we have derivative of this thing. So a is a constant, I can take it out, then it will be dt by dt, dt by dt is 1, so I have a plus derivative of bt square, so b I can take out, then it will be derivative of t square, So derivative of t square is equal to 2t, right?
Is it option D, sir?
Let's check.
D, sir.
Okay, let's check.
Yes, sir.
So then, okay, very good. So then this will be f minus 2t. So I will take the terms containing t on one side. So it is b times 2t plus 2t. It's equal to f minus a. If I take t common, then it will be 2b plus 1. Yeah, if I take that in denominator, so t is equal to f minus a divided by 2 times b plus 1. Okay, right, very good. It's option D. Then let's see the next question. If the velocity of a particle is v equals to at plus bt square, where a and b are constants, then the distance traveled by it between 1 second and 2 seconds is. So what should we do? We want distance traveled between 2 times.
Integral, sir.
Integrates, sir.
Okay, integrate velocity, right? So x2 minus x1 will be equal to integration of velocity v dt from t equal to 1 second to t equal to 2 seconds. Okay, we want that only from t equal to 1 second to 2 seconds. So we should integrate this. So this is equal to integration from 1 to 2 of at plus bt square dt. Okay, a we can take out. Then what is integration of t? So we have integration of t dt from 1 to 2 plus b we can take out, integration of t square dt from 1 to 2. Okay, so we know this formula of integration. Integration of t raised to n dt is equal to t raised to n plus 1 divided by n plus 1.
Option A, sir.
Okay, good.
Yes, sir. Option A.
Option A.
Everybody, right? Okay, so let me just finish it. So it is t raised to 1 dt from 1 to 2. Okay, so t raised to 2 by 2 from 1 to 2 plus you have b times t cube by 3 from 1 to 2, and that will be equal to a times t square is 4 by 2 minus you have 1 by 2. So this will be 3 by 2, right? Plus you have b t cube, so 2 cube by 3 minus 1 cube upon 3. So 8 by 3 minus 1 by 3, 7 by 3, right? It's option A. Good. Okay, so let's see next question. Next question is the x in meter. Okay, the position, this should be position. Okay, so wrongly they wrote displacement. So the position x of a particle of mass m moving in one dimension under the action of a force is related to time in second by this thing, t equals to square root of x plus 3. Then the position of the particle when its velocity is 0 will be. Now what should we do?
Differentiate that, sir.
Differentiate this directly. Okay,
So in terms of the position.
in terms of position. So we are given that the velocity becomes 0. That means we can find out dx by dt, right? So this is t equals to x plus 3. So we can take that 3 on the other side. So we'll get root x, right? We'll get root x equals to t minus 3, and then we can take square of that. So we get x is equal to t minus 3 square. Okay, and then since velocity is 0, we have dx by dt equals to 0. So it is just 2 times t minus 3, and this is 0. So v is 0 means that 2 times t minus 3 is 0. So 2 cannot be 0. So t equals to 3 seconds. This is what we have. So what is the question? What is the position at this time? So we have x equal to t minus 3 square. So what is position at t equals to 3? So x at t equals to 3 is equal to 3 minus 3 square, that is 0, right? So t is equal to 3. Okay, so answer is 0 meters. This is clear?
Yes, sir.
Yes, sir.
Okay, next question. A particle moves along a straight line OX at a time t in seconds. The distance x in meters of a particle from O is given by x is equal to 40 plus 12t minus t cube. How long would the particle travel before coming to rest? So particle is coming to rest, that means what is 0?
Velocity, sir.
Velocity is 0, right? So we have v equals to 0 at some time, that is dx by dt is equal to 0. Okay, so what is dx by dt? D by dt of 40 plus 12t minus t cube. Okay, so derivative of 40 is 0, derivative of 12t is just 12, 12 we can take outside, derivative of t with respect to t is 1, so it is just 12 minus derivative of t cube is 3t square. Okay, so what do we get? So this is equal to 0, therefore we have 3t square equals to 12, and this implies that t square is equal to 12 by 3, that's 4, so t is equal to plus minus 2. So which one is correct, plus 2 or minus 2? Plus 2, right? Okay, so then, oh, the Sai has a problem. She is logging in, logging out now, so she has a network problem. All right. Okay, so you have t equals to 2 seconds, right? T is equal to 2 seconds, right? Then how long the particle travels before coming to rest? This is the question. So how long does it travel? How will you find out?
So we have to substitute that t is equal to 2 seconds in that
X
distance equation.
distance equation. Is it correct? Actually what you should do is you have to find, okay, the distance it travels in 2 seconds. So you should take this thing. Okay, what does this mean? X at t equals to 2 minus x at t equals to 0 is the distance it travels in 2 seconds, right?
Yes, sir.
Okay, so if you take t equals to 2, then you have 40 plus 12 times 2 minus 2 cube, and minus you have t equals to 0. At t equals to 0, this thing and this thing will be 0, so it is just 40. Okay, let's check. 40 and 40 will get cancelled. This is 24, 24 minus 2 cube is 8, right? It is 16. Option A, right? This question is clear.
Yes,
Yes,
sir.
sir.
Okay, so then you can solve almost any question, okay, if this one is clear. So let us see next one. The position x of a particle with respect to time t along x-axis is given by this thing. where x is in meters and t is in second. What will be position of this particle when it achieves maximum speed along the x direction? Okay, so there is one more thing which I should have taught before coming to problems, and that is maxima minima. So it's simple. See, so now you have some graph, okay, xt graph you have, or let's suppose you have vt graph, okay, v versus t graph. So it is something like this, suppose. Okay, I'm sorry. Okay, so which is the point which has maximum velocity? This will be the point, right? Okay, we can find out that point. Here the velocity is maximum, so this is t. When velocity is maximum, I will say this is t max, time corresponding to maximum velocity. And how much is that maximum velocity? So this is the maximum velocity, okay, so this is v max, right? So now what is slope of this graph when velocity is maximum? What is slope of this graph when the velocity is maximum?
Acceleration, sir.
Yeah, how much is the slope of this graph at this point?
Zero.
It is 0. If you draw a tangent line here, what is slope of the graph? Draw a tangent line and find out slope of that tangent line. So it is 0. So that means when velocity is maximum, the slope of this graph will be 0. Okay, so slope of vt graph at t max is equal to 0. Okay, that means that acceleration is equal to what? 0, or you can say dv by dt, acceleration which is equal to dv by dt is equal to 0. Okay, so whenever any function hits the maximum value, the derivative of that function will be equal to 0. Okay, whenever some function hits the maximum value, the derivative of that function will be 0. Okay, then now how is the velocity changing? So acceleration is 0 here. What will be acceleration for any point which is after that? You take acceleration here, you take acceleration here. Okay, so here I can say acceleration would be positive. Okay, and now you have reached the maximum value of velocity. That means acceleration has become 0. If it remains 0, then what will happen? Velocity will remain constant after that point. If velocity is decreasing, that means acceleration has become negative, right? At this point, what has become negative? Acceleration has become negative, then only velocity will decrease. Okay, so if you take 2 points after that, what will be change in acceleration? Will it be positive or negative? At this point it is 0. After this point the acceleration is negative. Okay, a is negative. So if you take change in acceleration, will it be positive or negative? It will be negative, right? Okay,
Yes, sir.
acceleration here is 0, here it is 0. After this point, if you take another point, suppose here, so at this point the acceleration is negative. Okay, so change in acceleration, let's suppose this is a and this is Okay, let's suppose this is a1, this is a2. So a1 is 0, a2 is negative. What will be a2 minus a1? This is negative, right? So if I take a2 minus a1 divided by t2 minus t1, this will also be negative, right? Because change in time is positive. So what is this thing? So that is, if I take delta a by delta t, okay, this is going to be negative. So what is this thing? So if I take delta t tends to 0. Okay, this is, I am just taking a limit. Okay, so delta a by delta t is negative. That means dA by dt is negative, right? That means what is acceleration? It is one derivative of velocity. You take another derivative, you write d2v by dt square is negative. Okay, so the meaning is, if you have a function which hits maximum at some point, okay, which hits maximum at some value of variable, so then its derivative is 0 and its second derivative will be negative. Okay, its derivative is 0, its second derivative will be negative. Is this thing clear?
Yes, sir.
Yes, sir.
Okay, so in short, is it being very fast?
No, sir.
Okay, sure, everybody?
Yes, sir.
Yes means what? It is going fast, or you are understanding everything?
Understand.
Understanding level.
Okay, so at maxima, maximum point is known as maxima. Okay, derivative is 0 and second derivative of function is negative. Okay, so this is your maxima. Similarly, we can have minimum value of a function. Okay, so now velocity I have taken as an example. It can be any function. So in most of the questions we will need only first derivative. There will be very few questions actually where we will need to check second derivative. Okay, so this is the minimum point. Okay, so this is your VT curve and the velocity is minimum at this point. It is minimum, right? So this is t for which velocity is minimum, and this is that minimum value of velocity. Oh, sorry. So velocity is minimum at this point. So you can say that first derivative is 0 here also, because when it hits minimum, then also acceleration is 0, because derivative, okay, if you take derivative of velocity at this point, this is also 0, right? So if I draw a tangent line here, okay, actually if I draw a tangent line here, its slope is also 0. That means this is minima. Minima means minimum of a function. Okay, so at minima also, first derivative of function is 0. But now if you take second derivative, what will happen? So second derivative is change in acceleration. Okay, so here acceleration is 0. After this point, acceleration is increasing. So change in acceleration is positive. Okay, so when you hit the minimum, first derivative will be 0, second derivative is maximum. Sorry, second derivative is positive. Is positive. So in this particular example, dv by dt is equal to 0 and d2v by dt square is positive at t mean. Okay, is this thing clear?
Yes, sir.
Yes, sir.
Okay, so now you are given some function. So you are given x only. Okay, x in terms of t. This is x in terms of t, and you take its derivative with respect to time. It becomes 0. Suppose it becomes 0 at 2 points. Okay, this derivative, suppose dx by dt is equal to 0 at some time t1 and time t2. So now where will it be maximum and where will it be minimum? What will be the position, maximum position you can say, and minimum position? So you will take one more derivative. Okay, you will take one more derivative, and when the derivative, if you take second derivative, if it is positive, that means it is minimum point. If it is negative, that means it is maximum point. Is it clear?
Option A, sir, answer.
Oh, you found? Very good.
Yes, sir.
Okay, so you are right on to the target, right, while I am explaining. Okay, but is this topic clear to everybody?
Yes, sir.
Yes, sir.
Okay, all right, let's check. So the position x of particle with respect to time t along x-axis is given by x is equal to 9t square minus t cube, where x is in meters and t in seconds. What will be the position of this particle when it achieves maximum speed along the x direction? Okay, so first of all, let's find out speed, which will be dx by dt, and that is equal to d by dt of 9t square minus t cube. So this is derivative of t square is 2t, so it will be 18t minus 3t square. So this is v. Okay, we want maximum speed. For v max, dv by dt will be equal to 0. Okay, so that is d by dt of this thing, 18t minus 3t square is equal to 0. That is 18 minus 3 times 2t is equal to 0, and you get t equals to how much? Then 6t is equal to 18, that is t equals to 3. Okay, so fortunately you are getting only 1 point, and that's what I was saying, that you will get most of the times 1 point only. Okay, that is you are getting 1 time. So you get maximum velocity at this time. Okay, I mean derivative becomes 0 at 1 time interval only, not interval, 1 time only. So in problem it is given that it becomes maximum, so it is maximum at this time. Okay, but if you get 2 times, then you will have to check. Okay, so you got the time, but you want to find out what will be its position when velocity becomes maximum. So let's put x is equal to, it is just in terms of time. Okay, so x at t equals to 3 will be equal to 9 times 3 square minus 3 cube. So 9 times 3 square, 9 times 9 is 81, 81 minus 3 square, sorry, we have 3 cube is 27, right? So it is 54 meters. Option A is the correct answer. Very good. Okay, this is clear.
Yes, sir.
Yes, sir.
Okay, so now there are some more questions, 2 more questions. Okay, let's finish this one at least. A particle moves a distance x in time t. According to the equation, x is equal to this thing, t plus 5 raised to minus 1. The acceleration of particle is proportional to, this is what we have to find out. Okay, so first of all I will find out v is dx by dt, that is d by dt of t plus 5 raised to minus 1. And what will be its derivative? So it is minus 1 multiplied by t plus 5 raised to minus 2. Okay, right? Yes, no?
Yes, sir.
Okay.
Yes, sir.
And we want to find out acceleration, so we will take one more derivative. So acceleration is dv by dt. Okay, so that is minus 1 multiplied by derivative of this thing, d by dt of t plus 5 raised to minus 2. And what will be its derivative? Minus 2 times t plus 5 raised to minus 3. Okay, so this becomes plus 2 times t plus 5 raised to minus 3. So I can say it is directly proportional to, I have distance which is equal to t plus 5 raised to minus 1, and this is t plus 5 raised to minus 3. So I can say that it is directly proportional to x raised to minus 3. Is it there in the options? It's not there, but there are 2 other options which are related to velocity, so we need to check that. Okay, all right, so let us check that. Okay, so this can be related to velocity, right? Okay, so you can say that this is directly proportional to, v is directly proportional to x raised to 2. Okay, and a is directly proportional to x raised to not 3, minus 3, x raised to 3. So can I say v is proportional to x raised to 2? Yes, no?
Yes, sir.
See, x is t plus 5 raised to minus 1. You take square of that, you will get t plus 5 raised to minus 2. Okay, so v is proportional to x raised to 2. Then you have acceleration which is t plus 5 raised to minus 3. So if you take x cube, okay, this is x cube, you will get acceleration. So a is proportional to x raised to 3. Or if you want to relate acceleration with velocity, so from here what you can do is x is proportional to, you can say, v raised to half. Okay, so here I can put v raised to half. So what do I get? A is proportional to x raised to 3. That means instead of x, if I substitute v raised to half, so acceleration will be proportional to v raised to 3 halves. Okay, that is equal to v raised to 3 by 2. So this is your answer. It is option A. Is it clear?
Yes, sir.
Yes, sir.
Okay, so this was a simple question, and this question, a particle of unit mass undergoes one-dimensional motion. What's the time? Okay, a particle of unit mass undergoes one-dimensional motion such that its velocity varies according to v of x is equal to beta x raised to minus 2n, where beta and n are constants and x is the position of the particle. the acceleration of the particle as a function of x. Again, you want acceleration as a function of x is given by. Okay, so let's find out acceleration. So acceleration, we know we are given with velocity. So what is acceleration? It is dv by dt. dv by dt. But the velocity is function of x, right? So v is beta x raised to minus 2n, and you have d by dt of that. So then, okay, so here beta can be taken out, okay, and you have d by dt of this thing, which is function of x. So what should we do here? Can you tell me?
Chain rules.
Yeah, we should apply the chain rule. Okay, very good. So you have function of x and you are taking its derivative with respect to t. So what should you do? This is not x, okay. What should you do? You take derivative of this function with respect to x first and then take derivative of x with respect to t. Okay. So what is the function? X raised to minus 2n is the function. Okay. Very good. So we have to use chain rule here. So a is equal to, you have beta multiplied by, what will be derivative of this thing? So you have raised to minus 2n. So it is minus 2n multiplied by x raised to minus 2n minus 1. Okay. I have applied the formula of derivative of x raised to n. Okay. d by dx of x raised to n, it will be n multiplied by x raised to n minus 1, right? But what is value of n here? N is equal to minus 2n. Okay.
Yes, sir.
Yes, sir.
Right. And then you have dx by dt, but dx by dt is just velocity. Okay. And ultimately what do you want? You want acceleration in terms of x. Dx by dt is velocity. Okay. But you have velocity in terms of x. So this is good, right? So you have a is equal to beta, I can say minus 2n beta, na? Minus 2n beta x raised to minus 2n minus 1, and velocity is beta x raised to 2 minus, sorry, minus 2n. Okay. So beta times beta will be beta square. So you have acceleration equals to minus 2n, not eta, minus 2n beta square x raised to minus 2n minus 1 minus 2n. So minus 2n and minus 2n will become minus 4n, and you have one extra minus 1. So this should be the answer. Okay. This one, right?